Welcome back, Leanaholics. I'm your host, Dr. Luke. Today we're going to be talking about stability and capability. Now, stability answers the question of how is my process performing? It's the voice of the process. So it's saying, are we producing consistently and predictably? And then in capability, we're saying, am I capable of meeting customer expectations? And those customer expectations are given with the upper and lower specification limits. So you're most likely given a target and an upper spec limit and a lower spec limit. But first, let's talk about stability here real quick. Stability is that chart that looks like an EKG, and you're seeing it flashed up right now. And I say it looks like an EKG because some are above the mean, some are below the mean, right? So when you're inputting your data, there's some variation in the process. Now remember back to the beginning when we talk about the 4 process truths. Well, one of the process truths is that there is variation in every process no matter what. I don't care what your scenario, there's variation in the process, and that's okay to a certain point. How much of that variation is allowed? So for an example today, I'm using the individual moving range. So the top chart is the individual chart that we cover in class, and the bottom one is the moving range. And remember, let me step back a second. And the individual means on that top chart, each individual data point is being plotted out in its time series. And then on the bottom with that moving range, the reason you don't see a point number 1 is because over there in number two is actually the range between points 1 and 2, then 2 and 3, then 3 and 4. It's the range or the distance between those. So individual, moving range. All right, now back to my story here. When we see the variation there, you want it to be varying between those control limits. Now I mentioned spec limits, and those were given by the customer and worked out with the engineers, right? But now the control limits are the voice of the process. They're saying, hey, listen, here's the mean based on the data you give me. It's that center line. And then those lines on the top and bottom there, those are the upper and lower control limits. And those control limits, if we remember, there are 3 standard deviations above the mean and 3 standard deviations below the mean. And now that becomes important because if you remember back, we talked about the empirical rule. Well, if we're talking about 3 standard deviations above the mean and below the mean, well, we're talking about 99.7% of our data approximately. That means that between those upper and lower control limits, I would expect to see 99.7% of my data fall within those upper and lower control limits. So that means any data point that's above the upper control limit or below the lower control limit, that's going to send off alarm bells. And our response that you're taught is always to go and investigate it, no matter what. You need to go look at what went wrong in that. I mean, did somebody's computer glitch? Was somebody not at work this day? Is somebody a new employee? There's all sorts of things that could go wrong, right? Or that we have to investigate, but we have to find it out. Is it something that we actually need to make a fundamental change in the process for, or is it something that we just need to prevent from happening again? So again, and also, by the way, if it's above the upper spec limit and you're talking about time, for instance, what went wrong? Why did that happen? And how can we stop that one point from happening again? Or do we need a fundamental change, like I said earlier? But if it's below and you're talking about change, you go, well, maybe something happened that was really good here. Maybe there's something in there that we need to investigate and say, why is it on this day at this time, this particular mortgage was that fast? What went right? Are there things that we could pick up from that? But the whole thing is, when you're dealing with a point up or below those control limits, you've really you have special cause variation. So anything in the middle of those control limits is called normal variation, right? But if it's outside, how creative, it's called special cause. And the answer is always to go investigate what happened. So do we need to make a fundamental change, or was this just some sort of weird anomaly? Just remember too that special cause can be caused by other things. So outside of the parameters of this video, but I mean, there are like 14 different things that can go. If you're starting to see a trend constantly going up or a trend constantly going down, right? Or all of them are on one side of the mean and then they drop down all around the other side in a row. Something might be wrong there. We want to investigate. So we want to train ourselves to look for patterns. But if I'm out of control, I have to have an in-control process before I can make those inferences. Otherwise, I'm going to be way off the mark. But remember, there's different control charts for different types of data. Outside of the scope of this video, we talk about them in class. Now, onto the capability analysis. So if you're looking, for instance, using Sigma XL here, if you look up at the histogram in the top there, I mean, you look up at it, and in a lot of cases, you can visually see, does my data fit between the specification limits? If I have, if I'm supposed to get something done in 90 to 180 seconds and that's what I'm allowed, is my data between those spec limits? Yes or no? Does it look centered? There's a visual cue you can have, but you also have, well, here's a handy thing. Look what I'm circling right now. This actually tells me either all of my data is out of the upper spec limits or some of it's in the upper spec limits, some of it's falling outside of the lower spec limits, but it gives me the actual empirical data that I need. So am I capable of meeting customer expectations? The answer would be probably no. And I can just look at that. And there are other indices that you can use, like CP and CPK and all that other stuff, again, outside of the scope of this. Those are other indices that are used in certain industries. But Sigma Excel does a really good job of making it really easy for yellow belts and green belts to look at this data and just say, there it is, my data falls outside, or 82% falls outside the upper spec, and 12% falls outside the lower spec, and you're like, well, there you go, nice and easy, right? But I have to understand then what I'm going to do with that. And when I say what am I going to do with my control chart and then my capability analysis, I got to think to myself, let's go back to the beginning of the video. Are we stable? Are we producing our product or service consistently and predictably? Yes or no? And then are we capable of meeting customer expectations? Yes or no? And then if they're no, let's quantify that. And when we do, then we can get a little bit closer to getting into the analyze phase and say, okay, now let's look for the root causes and say, well, why not? So this is a brief overview of a really long section in our green belt, but hopefully it got you thinking again about some of the key concepts and terms that we had talked about. So I hope this helps with your capability analysis moving forward. Hope to see you in the classroom.